Hey everybody, Mr. Barry back here. We're going to do another synthetic substitution problem. Now remember, we already did this with the calculator. We're just doing it a couple different ways. We're going to try synthetic substitution here. And if you recall, when we plugged 3 in for this problem, it ended up being that we got that the function at x is equal to 3 was 98. So we're looking for a 98 here. We'll see how it goes. And we're doing synthetic substitution, which means I need to make sure this is not only in descending order, but every exponent on the way down is taken in care for. And that was the case in the last problem. We had a 3, a 2, a 1, and a constant. Here we take a look. And it's kind of interesting because we have an exponent of 4, then an exponent of 2. So on the way down, we missed an exponent of 3. And that's okay. We just got to take that into account. 1 constant. So that's 3 is the only one where that happened to us in this case. And here's how we take that into account. Again, I'm focused in on the coefficients here. So my quartic term here had a coefficient of 2. Then there was no 3, no exponent of 3. Since there was 0 exponent of 3, I want to make sure that I have a placeholder for a term that would be that case. Again, there's nothing there for the exponent of 3, so I'm going to put a 0 down. The exponent of 2 for the x has a -8. The linear term here is 5, and then we have our constant is -7. So again, 4, 3, 2, 1, constant. We have all of our terms, even the ones that aren't there, taken care of. We're evaluating x is equal to 3, so I'm going to put a 3 off to the side here. First step is to drop the leading coefficient. In this case, it's 2. And remember, the numbers that appear under this line right here, I'm going to multiply that term we're evaluating by, this number we're evaluating by. In this case, it's 3. So 3 times 2 is 6, and I'll do 0, and I'll put a 6 underneath there. Now remember up here, these numbers we're going to add. So I got 0 plus 6, that's 6. Multiply, 3 times 6 is 18. Up top above the line here, I'm going to add. So I have -8 plus 18, that's 10. Then I have another number underneath. 3 times 10 is 30. Number above, 5 plus 30 is 35. I do 3 times 35, and unfortunately you might need a calculator for this, but do it quickly in my head and say that it's 105. Finally, I'm going to add over here -7 plus 105, and look at that. Just like it was when it was in a calculator, the last number we have here is 98. That's the exact same number we got when we plugged and evaluated this with the x being 3 when we plugged it into a calculator. So it is possible. Maybe you like this synthetic substitution, but it's certainly an option for us, to avoid worrying about all the parentheses and the negatives that we have to type into calculators with exponents. A lot of options there. And synthetic substitution is certainly something we can use to evaluate our higher degree polynomials.